So hello everyone, this is the DSA's third presentation, which is for circular list or single linked circular list, which just simply means that circular list being implemented in single list manner. So we have had already two presentations, which is on single linked list and doubly linked list. And this is the third session on circular list. So what is a circular list? Excuse me. So circular linked list in which the last element is linked to the first element instead of being set to null. This structure allows the list to be traversed in a circular fashion. So you can see the diagram, the visual representation of a circular linked list, what it does and how it works. So it's basically a single linked list in a circular manner because we are only using a next pointer for a traversal of it, and the last element and next pointer is pointing towards the head, having it in a circular manner. So so most of the code that we have discussed will be similar to the one in the single linked list, and uh, so we'll be using the similar kind of header file also for circular list and its program. So these are the contents of the circular linked list. Just let me check. Okay, so these are the program for, and this is the header file contents for the circular linked list. We have the list elements with a data pointer and the next pointer. Then we have the list being implemented for the structure defined in the circular list. Then we have the list init, list destroy for initialization and destroying the list. List insert next and list remove next are similar to the one that we have discussed in the single linked list, and size, head, data, and next are the same implementations of what we have done in the single linked list. So now let's discuss a bit about the program. These are the header files that we'll need, where circular linked list clist.h is the one that we just saw. Then this is the initialization of the list, taking these arguments, and these are the uh, initial values to it. These are the destroy for removing each and every element in the list. Most of the implementation is going to be similar to the one that we have seen in the single linked list. There is a difference, and we'll point out. Before that, we'll only go through the contents or the major parts of the program in just a simple manner. So this is the insertion operation that is happening. So this is something that is different, because inserting an empty list in a circular list is different to one in the single linked list, because there is only one element. When we insert an element into an empty list, sorry, let me put it more clearly. So when we are inserting an element in the empty list, there is only one element that is, which is the one that is being inserted. So in circular list, the last element has to point towards the first element, or to itself, as there is no tail to it. So that is the only difference in implementation wise that one has to check. So as most of the implementation are same, these are the same lines that we have discussed. And so this is the insertion that I was talking about, when the handle insertion when the list is empty. So these are the operations that will it will take place. As you can see that the new element has to point to itself. But when the list is not empty, it's the same thing. It will keep. It is the same thing that we have discussed before. And because we are inserting, we are in incrementing the size of the list. Same for the removal of the list, removal of the element from the list. We will be using clist remove next. For this is the handle removing of the last element, because element's next pointer is sorry, yeah, this is the removal of the element from the list, and this is the removal of element from the last for the last element of the list, and after that it will be pointing towards head. So basically we are using the old element in order to store the value of the removing element to be stored in. So this has to point at this, and list head has to point towards null, which means that now the list is empty. If now we are handling the removal of the last element, so old element is the so these are some of the operations that will be taking place. If the old element is if the so this is the normal removal, but if the removal is happening at the head, then these are the operations that will be taking place, and the old element, what the removed element was pointing towards, will be assigned to the list head. So now uh, head will be pointing towards the element that the removed element's next pointer was pointing to. And because we have removed the element, will be using the free function and passing the old element in order to free the allocated storage. And because we are removing the element, we decrement the size of the list with this. So this is it for the circular linked list. And thanks a lot for listening and uh, being through these things, being through uh, the presentation. Thanks a lot.